Welcome back, my grade 8 math students from Tiger Valley College. We are continuing with our lesson on equations. Yesterday we did equations with more complex operations, and today we're going to look at solving equations using brackets or that contain brackets and fractions. Okay, let's look at example 1. As you can see, it says 3x plus 2 in brackets is equal to 10. So the first thing that we want to get rid of those brackets. And the way we do it, like we were taught in term 1, is through distribution. So we're going to distribute that 3 into the bracket. So the 3 is going to be multiplied by the x and by the positive 2. So 3 times x is 3x, and 3 times positive 2 is positive 6, is equal to 10. Step 2 is get your variables on the one side and your whole numbers on the other side. So you're going to have 3x is equal to get rid of that 6, remember you do the inverse, plus 6 minus 6. Or another way that I showed you is just throw them over to the other side. But very important, once you throw them over, the sign changes. The positive 6 becomes a minus 6. Okay, so you've got 3x is equal to 10 minus 6. So 3x is equal to 10 minus 6 is 4. And then lastly, what is happening to what is happening to the x? It's being multiplied by 3. What is the inverse of multiplication of 3? Dividing by 3. So 3x divided by 3 is equal to 4, and what you do on the one side you have to do on the other side, and 4 divided by 3. And then you could have written it as a mixed fraction 1 and 1 over 3, or you could have just left it as an improper fraction, x is equal to 4 over 3. Okay, let's look at example 2, just a little bit more complicated. There's brackets on both sides, and so the first step is to get rid of the brackets. So you're going to distribute that negative 4. Remember, please, if ever you did not listen to me now. That's 4. He has got a sign in front of him. He is a negative 4, and negative 4 needs to be distributed into that bracket. Same here. That is a negative 3. Sorry, it doesn't look so nicely, but negative 3 has to be distributed into the bracket. And please remember, when we distribute, we first distribute the sign and then the number. Your snare. First the sign, then the number, and then when we did exponents, we added the exponent rule as well. Okay, so now you've got, very important, that negative 4 needs to go in. 10x minus times a positive is a minus. 4 times 2x is 8x. Next, negative times a positive is a negative. 4 times 3 is 12, is equal to, please don't get caught in that 5 minus 3. Oh, looks so nice just to say 5 minus 3 is 2. Then to distribute 2 into that, that would be wrong. Remember, they try and catch you, that 5 minus 3. Oh, it looks so luring. Let's just say 5 minus 3 is 2. No. That negative 3 needs to be distributed in. So the 5 stays. Minus times a positive. Negative times a positive is a negative. 3 times x is 3x. Very important here. Negative times a negative is a positive, and 3 times 1 is 3. Okay, once you have that, once you've distributed your brackets in, and especially if you've got terms like terms on one side and on the other side, please people, just it's not a rule, but when you start throwing over, and you start throwing over lots of them, you are bound to make a mistake. So what I suggest is, please first simplify each side and then start throwing over. So once you can't simplify each side anymore, then throw one term, and then you've got your terms, all your like terms on one side. Okay, so please, first that 10 minus 8x is 2x. And over here, there's a 5 and a plus 3 that I can simplify. Positive 5 plus another 3 gives you a 8, and the minus 3x. So now you're left with 2 terms on each side. 1 must go over from each side, and it makes it much more easier than you throwing over the 3x here and the negative 12 there. You're bound to make more mistakes like that. Okay. Then you simplify. 2x plus 3x is 5x, and 8 plus 12 is 20. What is happening to the x? It's being multiplied by 5. What is the inverse of multiplication of 5? Divided by 5. Okay, what you do on the one side, you have to do on the other side. So 20 divided by 5 is 4, and 5x divided by 5, remember they cancel out like that, and you are left with the x there. Okay, example 3. This is the first time where we are now showing an example of division. So what is happening to the x? What is happening to the x? Okay, so please remember when we look at terms, it's very important to remember that a term is separated by a plus or a minus unless it is in a fraction form. Okay, so I'll show that again to you maybe with example 4. It's a little bit more evident. But over here, 3x divided by 5. So what is happening to x? It's being multiplied by 3 and it's being divided by 5. The first thing that we're going to do, we are going to, so the x is still attached. It's still attached to that 3x. They're still together. So what is happening to 3x? It's being divided by 5. So what is the first thing? What is the opposite? What is happening to 3x? Let me just follow these rules. What is happening to 3x? It is being divided by 5. What is the inverse of division of 5? Multiplication of 5. So we have to multiply with 5. So to get that divided by 5 times 5 away, to get the divided by 5 away, we times by 5. So that will cancel out, like I showed you. I just did it in fraction form so that you can understand, or just look at it, or just can understand it maybe a little bit better. But you times by 5 over 1. And remember the cross multiplication, I showed it here in the next step. You cross out that, and 3x over 1 just stays 3x. Okay, but what you do on the one side, you have to do on the other side. So when you multiply by 5 there, they cancel out. The only thing that is left is 3x is equal to 9 times 5 is 45. Okay, and then you say, all right, now what is happening to x? It's being multiplied by 3. What is the inverse? You divide by 3. What you do on the one side, you do on the other side, and you get x is 15. Okay, with these short sums, it's so easy to check your answer. So if you look at the original there, 3x over 5 must give you 9. So 3x we found as 15. If you replace the x with 15, 3 times 15 is 45. 45 divided by 5 does give you 9. Okay, so especially with these short sums, it's so easy just to quick check your answer. Okay, example 4. 2 minus 3y over 7 is equal to 2. So please remember, a term is separated by a plus and a minus unless they are in a bracket or when it is a part of a fraction. So if you have a look at this, this is one term. What is the most loose from this term is by that division, dividing by 7. Okay, so you always start with that. So you do the inverse operation of divided by 7, you times by 7. By timesing by 7 over 1, just to show you as a fraction form, that 7 and 7 cancels out, and then you are left with 2 minus 3y. But what you do on the one side, you have to do on the other side. 2 times 7 is 14. And from there, it's very simple. You just follow your rules where you throw all your whole numbers over to the other side and all your variables on this side. So when you take that 2 over, was a positive 2. When it goes over, it becomes a minus 2. What is left on this side, please remember your negative there. It's a negative 3y that's left is equal to 12. What is happening now to y? It's being multiplied by negative 3. Then you divide by negative 3. And you divide by negative 3 on the other side. So once you divide there away, that falls away, and you are left with your y, and y is equal to plus divided by a minus is a minus, 12 divided by 3 is 4. Okay, quickly, you can check your answer. You substitute the x in there, over there. So then you, in place of the x there, you put, sorry, it was a y. In place of the y there, you put a negative 4. So 2, negative times a negative is a positive. 3 times 4 is 12. Divided by 7. 2 plus 12 is 14. 14 divided by 7 gives you 2. Okay, the last example I want to show you, it involves where there's where there is a negative in front of the whole term on the one side. So I just want to show you just so that you know what to do when you find these questions. So if you have a negative in front, you've got negative, then a fraction. 3 minus 2x over 5 is equal to 1. So what did I teach you? Always you start with the inverse of divided by 5. The inverse of divided by 5 is multiplying with 5. Okay, so divided by 5 times by 5, that cancels out, and you are left with a negative, and that top part of the fraction, okay, is equal to 1, and you times by 5, 1 times 5 is 5. Just want to get back to this. I always say, once that fraction, because there's two terms on top there, once you bring it down, you take it, I always say, you take it off its high horse. Once it climbs off its high horse, that negative has to be distributed into both terms. Please don't forget that. That negative doesn't just belong to the 3, it belongs to that whole fraction. Okay, so once you take it off its high horse, always put those two terms in brackets. Once it climbs off, because it's cancelled out, climbs off its high horse, then please, you have to cotton wool it first. You have to first put it in cotton wool, and that negative has to be distributed into both terms, is equal to 5. Okay, so please remember that. When you take it off, always within brackets. Then you have negative 3, and that negative and negative becomes a positive, is equal to 5. So you take that negative 3 over, it becomes a positive 3. Then you get 2x is equal to 8. And once you simplify that, x is equal to 4. Okay, just very, very important there again. Please have a look. If a negative is in front and it's applicable to the whole fraction, once you take it off, once it's been broken up apart, and I always say, once it climbs off its high horse, please, that whole thing, that 2, because there's 2 terms in there, it's not just 1 term anymore, there's 2 terms in there, that negative needs to be distributed in. Okay. All right, grade 8s, I hope you have a wonderful day, and please have a look at the exercise that you must do, and keep well and keep safe. Goodbye.